Hello students, welcome back. I'm again back with my 8th part, same chapter. In the last video, we discussed about the significant figures. So I'll just continue with that part. So in the last video, we discussed about the significant figure. So what is the significant figure? So as I told you in the previous video, I'm repeating again the significant figures value. So basically, the number of significant figures in a measured quantity is equal to the number of digits whose values are known with certainty. I repeat, whose values are known with certainty plus the first uncertain digits. Means if we combine these two things, that is what the value with certainty plus the first uncertain digit will give us the significant figures. For example, if I am taking a one digit, that is what 160 centimeter, this is the measured value of length, is represented by 167 centimeter, and it can be also be as 160.0 centimeter, that is precise to 1/10 of a centimeter, and 160.0 centimeter precise up to 1/100th of the centimeter. So in these three cases, if we have the 160 centimeter represent only, so it has only three significant figures, that is 1, 2 and 3. So it has only three significant figures. But if we are taking the same digits in represented as 160.0 centimeter, so it has four significant figures. It means 1, 2, 3 and 4 significant figures. In the similar way, if we represent up to 100 of accuracy to 160 centimeter, it represents the 5 significant figures. So this is how we can just define significant figures. The next part, that is how we can assign or how we can determine the significant figure present in any physical quantity. So for this one, we have certain rules to find out the number of significant figures in a given physical property or physical quantity. So for this one, we have the 5 basic rules to identify or to find out the number of significant figures. For first rule, this is given as all the non-zero digits are taken as the significant figures. For example, if I am writing as the number 271, so it consisting of all the non-zero numbers, that is what non-digits. So therefore it has three significant figures. If I am writing as 1098, so if I am writing as 1098, so it may be taken as, sorry, I am just writing it, if it taken as 1998, so it consisting of all non-zero digits. So here you can say it consisting of four significant figures. Second rule for determining the significant figures is a zero having digits on its right side. I repeat, a zero having to its right side to digits is not the significant. Means whenever the zero is coming right side of the digit, it is not taken as the significant figures. For example, I am getting as 0.147, or if I am writing as 0271, so this 0 is not counted for significant figures. The similar way is this question is example 0.147 having only three significant figures. The third rule for this one is a 0 lying between the two digits is called as or taken as significant figure. For example, the number 6.023 have the four significant figures, or if I am taking as 1098 that we have taken previously, so it is having four significant figures. So this is the third rule. Now the fourth rule, a 0 having digits on its left may or may not be significant. For example, I am taking as 250.0, so this having the 4 decimal digits means what now here it is counted for the significant figures. And for this one, 1, 2, 3, 4, 5, now it has 5 significant figures, or it can be taken as that is 250, it has the 3 significant figures. Means what, the 0 just after the means on the left side of the digits can be counted, may or may not be a significant figures. And the fifth rule is in an exponential numbers, whenever the numbers are represented in exponential form, so in that part, the part which represent the exponents is not taken in the significant figures, but the remaining part means what, the numerical portion can be represents the number of significant figures. For example, the 2 into 10 to the power 3 is taken as has only one significant figure, that is 2. But if we represent this quantity in a similar way as 2.0 10 to the power 3, so here 2.0 means now 1 and 2, it has two significant figures. In this next case, if we are adding the same number as 2.00 10 to the power 3, except in this way we have taken as three significant figures. This is what the 5 rules for determining the number of significant figures in the given physical quantity. And next one is what the two terms related to find out significant figures and to measure any physical quantity by suitable device. Now we have two terms, that is what precision and accuracy. So basically we are just measure any quantity using any measurable device. So now the precision is defined as the degree of closeness, means how close we are measuring the physical quantity, means what percent or what kind of the error may be occur. So it is called what degree of closeness between the one value of a property and the other value of the same property subsequently measured by the same person, means the person is taking the different measurement of the same physical property by the subsequent method. So it may be some variation may occur. For example, if I'm just taking down the 160 centimeter, so if the person is measuring this quantity, so sometimes it may occur as 159 centimeter, or sometimes it may occur as 161 centimeter. So this one be the various we can say changes may occur. So this is how we are calling it precision. Whenever any person or same person is determining the same physical quantity by different method. So it is called as what the precision, means what the precision can be denoted as the individual value, means the value is measured by the person individually minus or subtracting by the arithmetic mean value. Whenever he is just taking out different values and finding out the arithmetic mean of all the values, and whenever the individual values minus arithmetic values taken as, we get as the precision, means how precise the quantity is measured. Next term is what the accuracy, means how accurate the physical quantity is measured, or how accurately the quantity is measured by the individual. And here it is called as what the degree of conformity of a measure to its value is termed as its accuracy, means how conformably the the physical quantity is measured by a person is termed as what the accuracy. So basically, in other words, it can be called as what the degree of agreement between a measured value and a true value, means it relates these two physical terms, that is what the true value and the measured value. Means if we have find out the measured value of the same some physical quantity and it has some true value, so if we are just comparing these two quantities, that is true value and measured value, we will find out the accuracy of the measured quantity. Means what the accuracy can be represented as the mean value of the particular physical quantity subtracting the true value of the same physical quantity. So this is called what the accuracy, and the previous one is what the precision. And last one is what that the accuracy of any measured device measured physical quantity can be depend on the two terms. First one is the accuracy of the device, and second is what the skill of the operator, means how skillful is the person which is operating the device, and the accuracy of the device means the device can be measured the physical quantity by how much accurately. So these two the factors on which any physical quantity can be accurately measured. So this is all about the significant figures, finding significant figures, and in this video, the next video will continue the law of chemical combination. Thank you. Thanks a lot.